Hi guys, welcome to God Academy. In this lesson, I'll be taking you through complex logarithm, complex powers. So, in our application of the Morvis theorem, we learned about how to simplify powers using polar form, right? Now, we are going to do complex logarithm and complex powers. Here, we are not going to use the Morvis theorem. We are going to use what we call logarithm, right? Now, let's see how this is done. Generally, if I give you any number, random complex number z is equal to, let's say, e to the power w, right? You realize that if I want to simplify this expression, I'll have ln z is equal to ln e to the power w, right? Ln z would then be equal to w ln e. So the only way to get a power down for simplification purposes is to use a natural logarithm. Either you are using the logarithm itself or the natural logarithm. So that's when you want to get a power down, okay, using the logarithm. At this point, you can say that ln e is what? Is 0. Okay, ln e is 0. Sorry, ln e just go away. So our ln z then becomes w, right? As simple as that. So we are just trying to simplify complex numbers using logarithm. So now let's see. But before we solve problems, whenever you see capital ln in complex numbers, this goes for the general argument. Please take note. General argument. And general argument is simply theta plus 2 pi a. Where the smaller letter ln goes for particular argument, or what you call the principal argument. Principal argument lies between negative pi and pi. So for whenever you are simplifying logarithm, which involves complex numbers, just use a principal argument and get a unified answer. Let's solve a couple of problems you understand. The first one says that we should find ln negative I. Ln negative I. So let me give you all the tricks. Whenever you are doing logarithm of complex numbers, okay, one thing you should just take note of it. Try and express any complex number within the argument of the ln as a polar form. If I had given you I ln 2, please, this thing we have here, don't convert I to polar form because I is not within the argument of ln. This one is simply an imaginary complex number, purely imaginary complex number. If you find the value of ln, you multiply by I, that's all. But when you have ln negative I, you have to convert the negative I within the argument of ln into polar form before we can simplify. When I give you negative I, realize that on the diagram, I'll have my positive row as this, positive um imaginary, negative row, and what? Negative imaginary. Negative I will fall at the negative imaginary. Is that not it? To fall down here at the negative imaginary. So now, how do we solve this? Converting I into polar form, that's negative I, you can point that directly on your calculator. So realize that it is negative pi on 2. Check. Our theta is simply equal to negative pi on 2. If you can observe, it's negative 90. Moving from what? The positive real axis. And as I said, so this one is actually the general argument. Okay. So for the general argument. Now, we are just taking the negative pi on 2. Okay. If not, if you want to take the other convention using the anti-clockwise, you have 90, 180, 270. Okay, 270. So what is that? So 270 is going to be 270 over 180, right? So 3 goes here, 9, 3 goes here, 6, 3 goes here, 3. So 3 over 2 pi. This is also another valid argument. So negative pi on 2 or this. Negative pi on 2 satisfies the, what do we say? Negative pi on 2 satisfies the principal argument where it should lie within 0 to 180, right? So for this, our first problem, So let's check something here. So whenever you are finding, you have different ways, two main conventions for finding arguments. Okay. So one of the convention is to take the anti-clockwise and one is a clockwise. But whenever you are taking the anti-clockwise, you realize that you can exceed 180 when you are within the third quadrant as well as you are within the final quadrant or the fourth quadrant, I would say, right? Okay. So let's go straight to the point. Theta is what? Negative pi on 2, right? That is your argument from the positive real axis. So please, in complex number, don't commit yourself, okay? Just try your best possible to always leave your argument with pi and negative pi. At this point, I'll have my lane. My negative I is now what? E to the power negative pi on 2 plus 2 pi k, right? I. And at this point, what do we do? So at this point, we are going to have our expression simplified as I multiplying pi on 2, negative pi on 2, right? I multiplying negative pi on 2 plus 2 pi k multiplying lane E. Once you have this expression, lane E, please, whenever you are doing complex logarithm, lane E just goes away, okay? It's just 1. It's 1, okay? So now our answer becomes I multiplying negative pi on 2 plus 2 pi k. This is for the general argument, okay? So how do we find a particular solution for this? So the principal value for this particular problem, which will be length I, let's say the one principal value is simply going to give us what? A negative pi on 2. Is that not it? Negative pi on 2. So we are going to have negative pi on 2 I. Okay. As simple as that. As simple as that. But the argument is simply pi on 2. Okay. So this is how we solve. It's very simple. Please, logarithm of complex number is simply you just trying to bring down a power, multiplying stuff, and re-expressing. That's all. Let's check this problem. Example 2. D is equal to I to the power negative 2i. What do we do? First thing, get your power down. Every time, get the power down. Okay. How do I get the power down? By taking logarithm. So ln z is equal to ln I to the power negative I. At this point, I'll have ln z is equal to negative 2i ln I. Okay. So now ln z is now equal to, when you take I is in the argument of ln. So please make sure you find the polar representation. So what's the polar representation of I? You go back to your Argand diagram. I will fall on my positive imaginary axis, and the argument is simply what? 90 from the positive real axis. So it's 90 pi on 2. So here I'll simply have E. You see, I is actually a unity, so it has no modulus of 1, just 1. So e to the power pi on 2, right? Then you can bring your plus 2 pi a, 2 pi a, all close I, as simple as that. So my lazy will simply be equal to negative 2i. Now, since you are doing logarithm, you can bring the power down. So I have pi on 2 plus 2 pi k, right? Pi on 2 plus 2 pi ki here. Then in lane E, simple as that. So here, what do? I multiply through. So lane Z equal to, now you can multiply through your 2i by this. So remember that this will cancel and I get negative pi, right? So 2 will cancel these 2 here, as simple as that. So I'll have, here will be pi on 2i, negative pi on 2i, because the negative 2i here is multiplying through. Okay, so once you have this done, then it will also multiply this. I'll have minus 4, so it should be plus negative. Okay, so minus 4. I have I times I, which will give me negative 1. So negative 1 times it become plus. Okay, so plus 4, right? Plus 4. Then you have pi k, as simple as that. Lane A is 1. At this point, you realize that the question didn't ask us to um the question didn't ask us. So please here too, I think I made some mistake here. Remember that the outside is multiplying everything inside. So let's see something. I was missing out something. Remember that this I is multiplying everything outside. So when I brought it down, I only introduced the I here. So please, there's I also here. So if I'm multiplying negative 2I times pi over 2I, 2 cancels 2, I times I is negative. So the answer is pi. Okay, positive. Then plus 4. So 2 times negative 2 is negative 4, but I times I is negative positive 4 pi k. Right, like this. Nicely written. Okay, pi k, like this. Then lane E is simply what? 1. Lane A is simply 1. So therefore, you are going to have lane Z to be equal to pi plus 4 pi k. But we weren't giving lane Z. They said you should solve for Z. So to take away Z, Z is simply equal to e to the power pi plus 4 pi k. As simple as that, you are done defining your logarithm. So this one was a typical complex power, right? And you have brought down, express it in complex logarithm first before we solved it. Okay, so you can see that clearly what you are doing is follows the same pattern. Let's check number 3. Solve for I to the power I, complex power again. What's the first step? Bring your I down. That's the first step. Bring my I down. I find lane I to the power I. This gives me I lane I. You can see an I within the argument of lane. What do? You find it the polar representation. So I lane, polar representation of, so let me make it this way. So I have I lane. Oh, I lane. Now the I here becomes what? E to the power. Now since it's I positive, right? Pi over 2 plus 2 pi k, or I. Pi is pi over 290 as we did initially. So here what do? You then bring your power back down. So I multiplying the expression pi on 2 plus 2 pi k I lane E. Then obviously lane E becomes 1. So at this point, I times I is negative. So negative pi on 2 minus 2 pi k is simply our answer for this expression. As simple as possible. And that is all I have for you in this lesson. Thank you for being with me in this lesson, and please like and you share.